The Domain Name System, or DNS, is a distributed service that provides naming for computers, and it is structured in a hierarchy. The hierarchy of DNS means that it is organized like an upside down tree, where each parent has many children. You can trace this tree to see the path from a subdomain all the way up to a top level domain. DNS is distributed, meaning that many different servers manage different domain names, giving the internet no single point of failure and allowing for infinite scalability. DNS acts like a phone book, translating a memorized domain name like www.example.com into a machine-readable IP address like 192.0.2.1. In order for DNS to know which names to link to a server, something called a resource record is used. A resource record has a specific structure, which is defined in the RFC. There are many different kinds of resource records, and they all work together to resolve where a name should point to. The fundamental basis of DNS, an A record is where it all starts. It maps a domain name to an IPv4 address, and it's what tells a browser to resolve a name to the host. A CNAME record denotes the canonical name of a host name, and points one name to another one. This simplifies maintaining multiple records by mapping the names to each other. This means that instead of changing multiple A records, you only need to change the one. An MX record identifies which mail servers will be used for a domain. This is required to receive emails with the name associated with the record. A text record allows free-form text to be associated with a domain. This is a simple, yet powerful tool that provides a flexible way for servers to communicate with each other. A text record can contain verification tokens for services, mail security protocols, and ownership verification records. A nameserver record is used to delegate domains to a DNS provider. This tells what nameservers should be queried for authoritative DNS information, which could be considered a source of truth for how a name should be resolved. An SOA, or Start of Authority record, provides essential information about how the DNS zone associated with the name should operate. It's sort of like having an administrative business card that holds all the important information for how our name should be treated. It includes important fields like the primary name server, the administrator's email, a serial number, the refresh time, the retry time, the expire time, and the minimum time to live. Using these fields, a given name server now knows how to treat this name and how to handle records about it. DNS setups are unique and tailored for each name, but there are always a few common records that most names need. Each name needs to have a record for its root domain. This is often an A record, but it could also be an alias record or a URL record, which are proprietary to DNSimple. Without one of these records, there would be no way to host a website or point a domain to a server. It is typical to have a record that points the common www subdomain to the same IP as your root name. This could be another A record pointing to the same address, a CNAME record pointing to the root name, or even a URL record that redirects to the base domain. To receive emails on addresses associated with a name, an MX record is mandatory and is required to point to which mail servers will serve the name. It is generally recommended to have multiple of these, with different content and different priority. CAA records allow you to control which certificate authorities and types of certificates are allowed to be issued for your domain. This controls the security protocols that encrypt traffic, such as TLS. If you have any questions, feel free to reach out to us at support@dnsimple.com. Want to give DNSimple a try risk-free? Visit dnsimple.com/signup. Need more information about how DNS works with DNSimple? Check out other videos on our channel and read our comic linked in the description. If you want more information about how TLS security works, watch this video next.